Hi student, good morning. Today talk about 11th standard physics lesson 2 kinematics. In this video discuss about evaluation 1 mark problems. So student, let's go to start with first problem. Which one of the following Cartesian coordinate system is not followed in physics? Already you know that x, y and z axes are drawn in anti-clockwise direction. Then the coordinate system is called right-handed Cartesian coordinate system. Suppose other coordinate system do exist in physics, we conventionally follow the right-handed coordinate system. Understand students? Okay. Now see which one is the Cartesian coordinate system not followed in physics. Option A. So x, y and z. So this is a anti-clockwise direction. So this is Cartesian coordinate system. And option B, x, y and z. This is also anti-clockwise direction. And third option C, x, y and z. This is also anti-clockwise direction. The first option A and B, C also anti-clockwise direction. So this is a Cartesian coordinate system in physics. And next option D, x-axis and y-axis, then z-axis. This is clockwise direction, x, y and z-axis. This is a clockwise direction. So student, this is a not coordinate system in followed physics. So the correct answer option D. So next second problem. Identify the unit vector in the following. It has a magnitude. Unit vector is nothing but magnitude equal to unity. That means 1. Understand students? Okay. So already you know that we can take position vector R along x direction and y direction. So I unit vector along x direction, j unit vector along y direction. That is coordinate, orthogonal unit vector. Okay, therefore modulus of r vector is equal to square root of I square plus j square. That is a magnitude speed. Magnitude of the particle, speed of the particle. Okay, now substitute option A. So what is the value of I unit vector plus j unit vector? Therefore square root of 1 square plus 1 square, that is equal to square root of 2. This is not unit vector. Okay, then option B. What is the value of I unit vector? 1 square. That is square root of 1 square is nothing but 1 divided by square root of 2. 1 by square root of 2. This is not unit vector. And the third one, K. 1 square minus the square root of 1 square minus 1 square divided by 2. Therefore, after get the answer square root of 1.5. This is also not unit vector. And finally, option D, substitute the square root of 1 square plus 1 square divided by square root of 2. So therefore, square root of 2 divided by square root of 2 and get our final answer modulus of r unit vector, that is equal to 1. This is a unity. So option D is correct answer. And next third question. Listen, which one of the following physical quantities cannot be represented by a scalar? Understand student? Which one of the following physical quantity cannot be represented by a scalar? The option A, mass. Mass is a scalar quantity. And option B, length. Length also scalar quantity. Are you clear, children? This is a directly you measured already. Mass is a scalar and length also scalar. Momentum is a vector quantity. Momentum is a vector quantity, therefore P is equal to mass into velocity. Mass is a scalar quantity, velocity is a vector quantity. So vector into scalar, that is a vector quantity. And option D, magnitude of acceleration. So this is a scalar quantity. Magnitude is nothing but a scalar. So here cannot be represented by a scalar. Momentum. Option C is a correct answer. Next, fourth problem. Two objects of masses m1 and m2 fall from the height h1 and h2 respectively. The ratio of the magnitude of their momenta when they hit the ground is. So student, two objects of mass m1 and m2, height h1 h2. Now calculate a ratio of momenta. So student, now tell me what is the formula for momentum? P is equal to mv. Now the first object of momentum P1 is equal to m1 into v1. Second object of momentum P2 is equal to m2 into v2. Therefore ratio of momentum P1 divided by P2 is equal to m1 v1 divided by m2 v2. Okay students. So students, now here in initial velocity of the object u is equal to 0. We consider initial velocity u is equal to 0. And using kinematic equation v square is equal to u square plus 2gh. Already we know that. Now substitute initial velocity u is equal to 0. Therefore v square is equal to 2gh. And v is equal to square root of 2gh. So student, the velocity and reaching the ground is v is equal to square root of 2gh. Now substitute the ratio of momenta P1 divided by P2 is equal to m1 divided by m1 into v1. Therefore v1 is equal to square root of 2gh1 divided by m2 into v2 square root of 2gh2. Now the same magnitude is cancelled, m1 divided by m2, therefore square root of h1 divided by h2. So this is the correct answer. So students, option C is the correct answer. m1 divided by m2 into square root of h1 divided by h2. Next, fifth problem. If a particle has negative velocity and a negative acceleration, what is speed? Increases or decreases? Now tell me, velocity of the particle along x direction, positive x direction, and also acceleration in positive x direction A. Suppose the particle along negative x direction, in opposite in x direction, acceleration also negative direction. This is a negative direction, velocity and acceleration of the particle. So students, the magnitude of speed is increases. Magnitude of speed is increases. That is nothing but velocity of the particle. So answer is option A. Next problem. If the velocity is v vector is equal to 2i unit vector plus t square j unit vector minus 9k unit vector, then the magnitude of acceleration at t is equal to 0.5 second. So student, a given data, velocity of the particle v vector is equal to 2I unit vector plus t square j unit vector minus 9k unit vector, and time taken t is equal to 0.5 second. Now tell me students, the acceleration of the particle a vector is equal to rate of change of velocity with respect to time taken. Therefore a vector is equal to dv by dt. What is the value of v? Now substitute here d by dt into 2I unit vector plus t square j unit vector minus 9k unit vector. Okay, now the differentiate of velocity of the particle. So 2I unit vector, it is a constant, that means magnitude number. So differentiate of constant 0, that value is 0 plus t square, the differentiate of t square. So 2t j unit vector plus minus 9, this is also magnitude, that means constant value, differentiate, that value is 0. Okay, a vector is equal to 2t j unit vector. Only we can calculate magnitude of acceleration. So student, this is a magnitude, modulus of a, or a is equal to 2 into, what is the value of t? 0.5. So multiply and get answer 1 meter by second square. This is the answer. So students, the option A, 1 meter by second square. Okay, next is 7th problem. If an object is dropped from the top of a building or tower and it reaches the ground at a time t is equal to 4 seconds, then the height of the building is, air resistance is neglected. So acceleration due to gravity value is given 9.8 meter by second square. Okay. Now see, when an object is dropped from the top of the tower, is nothing but building. The object is dropped, reach the ground at a time t is equal to 4 seconds. Now calculate height of the building h. What is the h value? Now listen, the initial velocity of the object here, initial velocity of the object u is equal to 0, and acceleration due to gravity, g, a is equal to z, because in downward direction, and given time taken t is equal to 4 seconds. Now calculate h. H is nothing but distance. So we know that distance of kinematic equation, s is equal to ut plus 1 by 2 at square. Now substitute the value s. S is nothing but h. H is equal to u. What is the value of u? Initial velocity. So this term 0, and 1 by 2 g into t square. So 4 square. So therefore h is equal to 1 by 2. What is the value of g? 9.8, already given, into 16. So now simplify and get the height of the building. H is equal to 78.4 meter. So this is a correct answer. So students, option B, 78.4 meter. Next problem, 8.1. A ball is projected vertically upwards with a velocity v. The ball comes back to ground in time t. The velocity time graph is show the motion correctly. So students, now taking a ball through upward direction with a velocity v and an acceleration due to gravity in opposite in direction of the particle, that means downward direction, a is equal to minus g. Okay. Next, slope of velocity time graph. The first graph, now see, velocity time graph, that means acceleration. Acceleration due to gravity is constant. So students, this graph will be the particle through some speed, that means some initial velocity u. So the particle go to upward direction, velocity of the particle decreases. So no need to correct motion. And the second one, the particle come to down, velocity suddenly increases, go to reach at a ground, that the velocity is 0. But here the velocity after decreases in the same axis. So this is not correct motion. But option D, the total displacement is negative, so no need to calculate the answer. But option D, so option C is the correct answer. Here the particle comes back to ground in time t. So the velocity time graph is acceleration. So this is a correct answer. Okay, then another problem, if one object is dropped vertically downward and another object is thrown horizontally from the same height, then the ratio of vertical distance covered by both objects at any instant time t. So students, one ball fall vertically and another ball is projected horizontally. This is a vertical direction, this is a horizontal direction with some velocity. What is the initial velocity? Initial velocity is 0. Are you clear? Okay. Both the ball will reach the bottom at the same time. So, but on a reaching the point same time. Okay. Then the vertical displacement we call it is y1, horizontal displacement we call it is y2. By using kinematic equation, distance of kinematic equation, S is equal to ut plus 1 by 2 at square. What is the value of initial velocity? That is equal to 0. U is equal to 0, initial velocity. Okay. Then A, acceleration due to is a constant. So therefore A is equal to G. In vertical displacement, y1 is equal to 1 by 2 gt square. This is equation number 1. And another object, horizontal direction. That means horizontal displacement of y2 is equal to 1 by 2 gt square. Here also u, initial velocity 0. So these two equations can be divided and get answer 1. So student, the correct answer option A 1. Next up, 10th problem. A ball is dropped from some height toward the ground. Which one of the following represent the correct motion of the ball? Now see your first option. The velocity of the particle or ball is dropped from some height toward the ground. Which one of the following represent the correct motion of the ball? So every instant of time of the particle, velocity of the particle increases. Say for example, the first instant of time t, the velocity of the particle 1 meter by second. After next instant of time t 5 meter by second. The velocity of the particle 5 meter by second. That is, acceleration also increases. Velocity of the particle increases, acceleration also increases. So next instant of time, velocity of the particle 10 meter by second. So this is a possible. So student, the answer is option A. It is correct motion of the ball. Next problem, go to discuss about if a particle execute uniform circular motion in the xy plane in clockwise direction. That means the particle rotate in clockwise direction, then the angular velocity is in which direction? So students, now taking a xy plane, x-axis and y-axis, the particle rotate in clockwise direction. The velocity of the angular velocity of the particle omega. Now we have to use corkscrew rule. Take a screw, rotate in clockwise direction, the direction of screw inward along a negative z axis. So student, listen to it. This is inward direction along negative z axis. The particle rotate in clockwise direction. Suppose the particle rotate in anti-clockwise direction. This is anti-clockwise direction. The direction of the screw outward along positive z axis. Positive z axis. So students, now here uniform circular motion in the xy plane, the particle rotate in clockwise direction. So the particle, the direction of the screw, that means particle inward direction along negative z direction. So student, answer is option C, minus z direction. Understand? Okay. Then next problem, if a particle execute uniform circular motion, the particle execute uniform circular motion, choose the correct statement. Now listen to it. Uniform circular motion, the velocity is always changing but speed is remains constant. Understand students? Now listen to it. Here the particle moving in a uniform circular motion. So velocity is not constant. That means the direction changing. Though velocity of the particle this direction, here this direction, but the speed is remains constant. The velocity vector remains constant and only the direction changes continuously. But a centripetal acceleration, this is a centripetal acceleration. In uniform circular motion, velocity vector turn continuously without changing its magnitude, that means speed. So students, here the magnitude of centripetal acceleration, is constant for uniform circular motion, but centripetal acceleration is not constant but take different direction during the motion. So here the speed is constant, velocity is not constant, acceleration also not constant, but magnitude of acceleration here constant. So now tell me, what is the correct statement of particle? First one, the velocity and speed. Already you know that velocity is not constant, so this statement is wrong. And the second one, acceleration also not constant, so this statement also constant. Okay, then velocity, acceleration, both are not constant. So this statement also wrong. So finally, the speed and magnitude of acceleration are constant. So speed and magnitude, that means modulus of acceleration A, both are constant. So answer is option D. Understand, students? Okay. Then go to next problem. If an object is thrown vertically up with the initial speed u from the ground, understand, the particle thrown vertically up with the initial speed of u from the ground, then the time taken by the object to return back to the ground. So now this is an object throw vertically upward direction. Understand, students? Vertically upward direction. Initial velocity u. Initial velocity u. The particle go to upward direction. Acceleration of the particle a. Acceleration due to gravity in opposite in direction. So negative. A is equal to minus g. The particle of the displacement s is equal to 0, because so particle go to upward direction after come to reach at a ground. So total displacement of 0. Time, initial time 0, after final time capital T. So now using distance of kinematic equation, we know that s is equal to ut plus 1 by 2 at square. What is this? Total distance of displacement is 0. S is equal to 0. Now substitute here initial velocity u t, that is equal to capital T, ut minus, that is a is equal to acceleration due to gravity in opposite in direction minus 1 by 2 g t square. So this is a negative term, come to left side. So ut is equal to 1 by 2 g t square. So the same magnitude is cancelled, t, and finally we get the answer t is equal to 2u by g. This is a correct answer. So the total time taken by the object to return back to ground, answer is option D. So this is a option D, 2u by g. Next, 14th problem. Two objects are projected at an angle 30 degree and 60 degree respectively with respect to the horizontal direction. So student, two objects projected at angle 30 and 60 degree. Now calculate the range of two objects are denoted as r30 degree and r60 degree. Choose the correct relation from the following. So students, the first object projected at angle 30 degree. Second object projected at angle 60 degree. Now tell me, what is the formula? Range. Range is equal to r is equal to u square sin 2 theta by g. Then here using first object projected at 30 degrees, the range of object or 30 degree is equal to u square sin 2 into 30 degree. So 60 degree, sin 60 degree divided by g. And tell me, what is the value of sin 60? Root 3 by 2. So r 30 degree is equal to u square by g into root 3 by 2. This is the first equation. And second object projected at angle 60 degree, that is equal to u square sin 2 into 60, 120, sin 120 degree divided by g. Now r 60 degree is equal to u square by g into sin 120 degree, that value is root 3 by 2. This is equation number 2. So students, here equation number and equation number 2, 1 and 2 both are equal magnitude, u square by g into root 3 by 2. So r 30 degree is equal to r 60 degree. Now understand students, the range is same for the angle of projection, 30 degree and 60 degree. So answer is option A, r 30 degree is equal to r 60 degree. And go to final problem in this lesson. An object is dropped in unknown planet. It's not Earth planet. This is unknown planet from height 50 meter. It reaches the ground in time 2 seconds. The acceleration due to gravity in this unknown planet is. Understand students? In unknown planet, the object dropped from height of 50 meter, reached the ground in 2 seconds. So calculate the acceleration due to gravity. Okay. Now consider unknown planet. This is a unknown planet. The object thrown. So this is a object at a 50 meters, height of 50 meter. Your initial velocity 0, u is equal to 0, and acceleration due to gravity g, a is equal to g. So now using distance of kinematic equations, s is equal to ut plus 1 by 2 a t square. Already you know that this is a kinematic equation. Now substitute the value s. S is nothing but height of 50 meters is equal to initial velocity, that value is 0. So here total term 0, ut 0, and 1 by 2 a is nothing but acceleration due to gravity g, 1 by 2 g t, already given 2 seconds. So 2 square, that means 4. So here for simplify this equation, 100 is equal to g into 4. I want acceleration due to gravity, g is equal to 100 divided by 4, that is equal to 25 meter by second square. That is a unit of acceleration due to gravity, meter by second square. So that value 25. So answer is option B. So option B, g is equal to acceleration due to gravity, g is equal to 25 meter by second square. Understand students?